Hello. What we're going to go over now is the Amiga Vista for the chapter on conics. And what I want to find here is the center and radius. So since it's at x squared and y squared, there's no phase shift. It's going to be centered at 0, 0. And the radius is going to be at the square root of 81, which is 9. For the next problem, it's just x squared, so that's going to be a 0 associated with that. And then we do the opposite for the phase shift. So that's going to be positive 3. And then the square root of 144 will give me 12. Opposite, so it's going to be negative 5, positive 4, square root to 25, and that will give me 5. Opposite, there's nothing associated with that, so there's going to be a 0 for the y. So it's going to be negative 3, 0, and the square root of 1 is just plain 1. Now we're going to kind of do the reverse. Given a center and a radius, I want to write the equation. So I'm going to set up this template. X plus or minus something squared, y plus or minus something squared equals something. So I do the opposite of the 3, so the opposite of plus 3 is minus 3, the opposite of plus 7 is minus 7, and then I square that, so 3 times 3 will give me 9. Same setup over here. I'm going to set up a parentheses, but it's going to be the opposite of that, plus 7, squared, plus y plus 3, opposite of minus 3, squared equals r squared, which is 25. You can do these pretty rapidly. Centered at the origin, 0, 0, that's just going to give me x squared plus y squared, and then 1 times 1 is just 1. Now to name that conic, you're supposed to know that if it's a plus sign between, it's either going to be a circle or an ellipse. And because it's not the same thing underneath, this one has to be an ellipse. This here is the format for a circle, for the equation of a circle. There's nothing underneath, and it's set equal to a number 4. So that's going to give me the equation of a circle. This one, if it's just y equals something squared, x squared, that one's going to be a parabola. And this one, if it has a minus sign, that's going to be what we call a hyperbola. I want to sketch the graph of each conic section that I have here. So the center's at 0, 0, and the radius is the square root of 16, which is 4. So I'm going to place the center at the origin, and then I'm going to go out 1, 2, 3, 4, 1, 2, 3, 4, up 1, 2, 3, 4, left 1, 2, 3, 4, down 1, 2, 3, 4, and try to connect those dots as best as I can to make it an acceptable circle. Not bad. For this one, it's an ellipse. Because it's x squared, y squared, it's centered at 0, 0. But I go left and right, the square root of 9, which is 1, 2, 3, left 1, 2, 3. I go up and down, which is associated with the y value, 4, the square root of 16, 1, 2, 3, 4, 1, 2, 3, 4. And I'm going to connect those dots with a nice vertical ellipse. Now, we're not doing it on this graph, but for an ellipse, there's a focus somewhere in that area and that area. This one's a hyperbola. A lot of work on the hyperbola. Centered at 0, 0. I go right and left 2. I go up and down the square root of 9, which is 3. Now, I don't just draw a shape. I have to draw what we call an asymptote box. And that goes through those vertices. Now I have to draw a slant asymptote, which connects the vertices of that rectangle I just drew. Now I'm going to actually draw the curve. And because the x squared comes first, the curve is going to come along on the x-axis and go through the x-axis. There's an x-intercept if x squared comes first. No y-intercept. And it goes along that and approaches that asymptote until infinity. More graphs of conic sections. These have phase shifts. So this center is at negative 3, positive 1, and the radius is 2. So I'm going to go left 1, 2, 3, up 1. And then from that center, I'm going to go right 2, up 2, left 2, and down 2 from the center because that's my radius. And then I'm going to do a quick sketch of that circle. For this one, the center is going to be located at the opposite 1, the opposite 2. So I go right 1, up 2, and put the center for my ellipse. Now the square root of 4 is 2. So for the x value, I'm going to go right and left, 2 away from that center. The square root of 9 is 3. So for the y values, I'm going to go up and down, 3 for that y value. I'm going to connect those dots. Don't forget, for this ellipse, there's going to be a foci out there in that area. I didn't label the foci for the other hyperbola, but I will on this one. The center of this hyperbola is going to be 3, negative 2. So I go right 1, 2, 3, and I go down 2. Now, the square root of 16 is 4, so I'm going to go right 1, 2, 3, 4 from that center, and left 1, 2, 3, 4 from that center. The square root of 9 is 3. I'm going to go up 1, 2, 3 from that center, down 3 from that center. I'm going into my actual problem. And I'm going to draw the asymptote box, which goes through the problem. Kind of annoying, I know. Now I'm going to draw the asymptotes. And because it's x squared, the actual graph is going to come along the asymptote and go through that value. Just tangent to that point. Come along that asymptote. It doesn't go into the box. It just touches at that coordinate and it goes out forever. Now, for hyperbolas, the foci are going to be located in the actual outside of the curve. And it's nested in the little concavity part.
For this exercise, I want to work backwards. I'm given a graph and I want to write the equation. So it's a circle centered at 0, 0, so it's going to be x squared plus y squared.
and that's going to be equal to whatever the radius is squared. So the radius is 2, 2 squared is 4. This is an ellipse centered at 1, 2, 1, 2, 3. So I'm going to set that up. It's going to be parentheses x minus 2 squared plus, because it's an ellipse, y in parentheses minus 3 squared equals 1. Now I have to figure out what the values are for a and b underneath. Notice I go right 2, so with the x value I'm going to square 2. That would give me 4. That goes up 1, 2, 3, 4 from the center, so that's going to give me 16. A hyperbola, I'm giving the vertices in the center. The center is located at 0, 0, so no phase shift. So that's going to be easy enough, just an x squared, y squared. Minus sign equals 1. Now how far is this vertex from the right? 2, 3. 3 squared is going to give me 9. How far up and down do I go? 1, 2. 2 squared is going to give me 4. I have a circle with a phase shift. It goes left 2, so the center is going to be at negative 2. And it goes up 1, 2, 3, 4. The center is at negative 2, 4, and the radius of the circle is 1, 2, 3. So I'm going to come over here and write the equation of that circle. It's going to be the opposite, x plus 2 squared plus y minus 4 squared equals whatever 3 squared is, and that's 9. Now the equation of the ellipse, it's not centered at 0, 0, so I have to find the phase shift. 1, 2, 3. Goes left 3, up 2. So that's going to give me x plus 3 squared plus, because it's an ellipse, I put a plus sign. And then I put y opposite minus 2 squared equals 1. And then I have to find out what goes underneath the a and b. So it's going to be 1, 2, 3, 4. 4 squared is 16. And I go up 1, 2. 2 squared is 4. Ooh, this is a scary hyperbola because it's going a different direction. All that means, it's centered at 0, 0, is that y squared comes first. Minus x squared equals 1. Now the value associated with y is going to be vertical from the center. So that's 4 vertically from the center. That's going to give me a 16 underneath. And it's 2 in the horizontal from the center. So that's going to give me a 4 because 2 squared is 4. I'm going to graph the conic section and then list some of the critical information about the graph. Centered at 0, 0. I go right 5, 1, 2, 3, 4, 5, because the square root of 25 is 5. Left 1, 2, 3, 4, 5. I go up 4, because the square root of 16 is 4. 1, 2, 3, 4. And I go down 1, 2, 3, 4. This is an ellipse. So I want to find the vertices of the major axis. For the ellipse, that's going to be the long axis. So that's simple enough. It's just going to be located at 5, 0 and negative 5, 0. Right there and right there. So I'm going to label those negative 5, 0 and 5, 0. Now I want to find this thing called the foci. To find the foci, you take these two numbers and you subtract them. I know it goes against your intuition that you would add them, but you do the opposite of that symbol. So 25 minus 16, that's going to equal the square root of 9, which is equal to 3. Now I should put a plus minus because from here I'm going to go plus, which is right 3, and that's a focus. I'm going to go left, minus 3, 1, 2, 3, and that's a focus. So I have two foci located at negative 3, 0 and 3, 0. This one, another ellipse. Centered at 0, 0, I go right 1, 2, 3, left 1, 2, 3, because the square root of 9 is 3. I'm going to go up 1, 2, 3, 4, 5. I'm going to go down 1, 2, 3, 4, 5, because the square root of 25 is 5. Draw the curve, the shape. I'm getting pretty good at this. Now, the vertices of the major axis are going to be located here and here, because once again, it's the long side. So that's 0, 5. And this one is 0, negative 5. So I'm going to label those as 0, 5. I should put the negative first. It doesn't matter. And 0, 5. Now the foci, square root of 25 minus 9. You don't want any imaginary numbers here, so you put the big one first. That's going to give me the square root of 16, which is plus minus 4. So from here, I go plus 4, up, 1, 2, 3, 4. And I go down 4, minus 4, 1, 2, 3, 4. And those are my foci. So that one's going to be located at 0, 4, and this one's located at 0, negative 4. Graphing this hyperbola, because it has a minus sign, x squared, y squared, it's going to be located at 0, 0 for the center. The square root of 9 is 3, so that means I'm going to go right 3 and left 3. And then the square root of 16 is 4. I'm going to go up 1, 2, 3, 4. I'm going to go down 1, 2, 3, 4. Now, again, this is a hyperbola because of the minus sign. That means I have to do a lot more sketching. It's not really difficult. It's just a lot more work. So I'm going to do the asymptote box. Then I'm going to sketch the asymptotes. Slant asymptote, slant asymptote. And now the actual curve, because it's x squared, will cross the x-axis. So it's going to scoot along here, be tangent at that coordinate, and then go down along that asymptote. And again, that's the shape of it. Now, to get the particular information, the vertices of the major axis, are where it crosses the where it crosses the major axis and the curve. So that's going to be 1, 2, 3, 0, and negative 1, 2, 3, 0. Now, the foci or foci is located at 9 plus 16, which is kind of strange, isn't it? Instead of adding or subtracting, you add them. So 9 plus 16, and there's a reason for that. 9 plus 16, that gives me the square root of 25. That's going to give me plus or minus 5 away from the center. So that means I go right plus 1, 2, 3, 4, 5. That's going to give me a foci, or a focus, at 5, 0. And the other one's going to go left, negative 5, 1, 2, 3, 4, 5. So that's going to be at negative 5, 0. And the reason you do the opposite is because it pushes the focus into the concavity of the curve. It would be kind of not an important point if it were outside of the concavity of the curve. So the other focus is going to be at negative 5, 0. This one has a phase shift, so it's going to be a little bit more difficult. And it has the y term first. So because it has the y term first, that means I go opposite, up 2. The x term stays 0, so I don't go left or right any. The phase shift is going to be 0, positive 2. Square root to 9, that means I go up and down 3. 1, 2, 3, down 1, 2, 3. I square root to 16, I go left from the center. 1, 2, 3, 4. Left, 1, 2, 3, 4. I'm going to draw the asymptote box because it's a minus sign. It's a hyperbola. Now I'm going to actually sketch the slant asymptotes that go through the vertices of that rectangle, the diagonals of that rectangle. Now, because it's y squared first, the curve is going to go through the y-axis. Goes through the y-axis. The vertices are going to be located at 1, 2, 3, 4, 5. The coordinate 0, 5. And the coordinate 0, negative 1. It's centered along the center of the hyperbola, but you still have to use the xy axis to locate or designate those coordinates. The foci are going to be located at 9 plus 16. Again, square root of 25 plus or minus 5. So from this center, I go up 1, 2, 3, 4, 5, and that's one of my foci. I go down from the center 1, 2, 3, 4, 5, and that's the other foci. And here we go. That coordinate for the first focus is located at 0, 1, 2, 3, 4, 5, 6, 7. 0, 7, and then this one's located at 0, 1, 2, 3, 0, negative 3. Thank you.